Hello, geniuses! Today, we're tackling a classic exercise on vectors and point alignment.
Here is the problem. Consider a triangle ABC and 3 points E, M, and F defined by these relations. BE equals minus 1/3 of BC. CF equals 4/5 of CA. And BM equals 1/2 of BA. The question, show that E, M, and F are aligned.
Let's go. We start by drawing our triangle, ABC. First objective, place point E. We know that vector BE equals minus 1/3 of vector BC. So let's draw BC and divide it into 3. Here is 1/3 of BC, but wait, there's a minus sign. That means we reverse the direction. We pivot, and E ends up right here. Now for point F, we need vector CA. We divide CA into 5 equal parts. CF is 4/5 of CA. Let's count. 1, 2, 3, 4. F is right there. Last point, M. This is the easiest one. BM is half of BA. Here's BA, we cut it in half, and M is right in the middle. Now, look closely. We draw a line passing through E and M. It also passes through F. The 3 points are aligned. We can see it, but we have to prove it. Time for the math. We are going to express vectors ME and MF in terms of AB and AC. Vector ME. We apply Chasles relation, passing through B. ME equals MB plus BE. MB is the opposite of BM, so we write minus BM plus BE. We substitute. BM is 1/2 of BA, and BE is minus 1/3 of BC. Let's plug them in. We simplify the signs. Minus times 1/2 of BA gives plus 1/2 of AB, and minus 1/3 of BC stays as is. Now, our goal is to have only AB and AC. We decompose BC. BC is BA plus AC. We distribute the minus 1/3. That gives minus 1/3 of BA minus 1/3 of AC. Minus 1/3 of BA is plus 1/3 of AB. We group the coefficients of AB, 1/2 plus 1/3, all times AB, and we keep minus 1/3 of AC. 1/2 plus 1/3 is 5/6, and there is our final expression for ME, 5/6 of AB minus 1/3 of AC. Let's move on to MF. Chasles relation, passing through C. MF equals MC plus CF. MC, we decompose it again with Chasles. MC equals MB plus BC. That gives us MB plus BC plus CF. We decompose everything. MB becomes minus BM. BC splits into BA plus AC. And CF is 4/5 of CA. We replace BM with 1/2 of BA. Then we flip the vectors. BA becomes AB. CA becomes minus AC. Everything falls into place. We group them, the ABs together, 1/2 minus 1. The ACs together, 1 minus 4/5. We calculate. 1/2 minus 1 is minus 1/2. 1 minus 4/5 is 1/5, and there is MF. Now, the key moment. We factor MF by minus 5/5. Look closely at what is inside the parentheses. 5/6 of AB
minus 1/3 of AC. But that is exactly ME. So MF equals minus 3/5 of ME.
MF is a multiple of ME. The vectors are collinear, and since they share point M, E, M, and F are aligned. The proof is complete.